All right. Hello. So today we will do. Let's see what we're gonna do. So we finish. So as of right now, we finished 6 exercises, right? And the last one we did was this one. Standard deviation of a discrete random variable. And so we kind of finish the 6 exercises here in discrete. So today we're going to start on continuous. So let's review, right? The difference between discrete and continuous. Discrete random variables are random variables that take on values that we can count. Things like number on a dice, right? Numbers on a die, which is 1, 2, 3, 4, 5, 6, and then continuous, which is kind of the other side of it, are random variables that take on values that you can't really count, but you can measure them. Things like time, things like maybe distance, but depends on what kind of distance you are doing. Height, weight. So those are all continuous random variable. So let's look at probability in density curve. All right, probability in density curve. So if you take a look at this, all right, take a look at this right now. So consider the density curve. Right, density curve. Right, density curve. Um, the things that you need to understand about density curve. Number one, area under the curve. So if I were to use a different color, area under the curves. Right now, this density curve, it's like a distribution. It goes from 0 to 2, and it rises like this, and then it flattens it out. So the area, right? Area under the curve, area under the density curve, area under the curve, right? Area under the density curve. Density curve always is equals to 1, right? Will always be equals to 1. And another thing that you can think about area is think of area as probability. Okay, probability. So think about area as probability. So 100% is what? 100% means that there's a 1, right? It's equals to 1, which is it's the same as talking about 100%, because 100%, isn't it 1.0, right? It's 1.0, right? So here they ask us to, let's see, I'm going to erase this, and let's look at what they ask us to find. Where x is greater than 2. So x is 2 right here. Greater than 2 is this area here. And then all the way to 6, because it ends at 6. So we're supposed to find all this area. So area, it looks like it's a rectangle, right? So area of rectangle is what? It's length times width, right? Area of rectangle is length times width. Area of rectangle is length times width. And here the length is from 6 to 2. Oh man, I don't know how this is. Okay. Length is 6 minus 2 is 4, right? Is 4. And you can also count 1, 2, 3, 4. And what's the height? The width right here is 0.2. The width is actually 0.2. And so 4 times 0.2 is 0.8. Yeah, that looks about right, right? 0.8. So the answer here is 0.8, right? 0.8. That's the probability. Probability is the same meaning as area under the curve. Before I proceed, let me maybe, well, actually, I don't. I don't need. I wanted to actually tell you what the formula is for area of a triangle, area of a trapezoid, but maybe I don't need to talk about it here. Maybe it will come up later on in the example. So 0.8, it's the answer, and let's see, 0.8. Woohoo! So let's see. Next question. Ah, it's a good thing I didn't talk about the triangles earlier. So here, the area under the curve would the entire thing would be from here all the way to 3, and then from 3 all the way to 5. So here, area under the curve, when you add those two area up, it will be equals to 1. Okay, but here they ask us to find the probability that x is less than 3. X is less than 3, starting from here, less than 3. So this is the area under the curve, which is also equivalent to probability, and this is what we need to find. Now that looks like an area of triangle, right? Area of triangle. And area of triangle has this formula: half times the base times the perpendicular height, right? Perpendicular height. Okay, the perpendicular height. So let's put half, and the base is what? Base from here to here. Look at the bases. I always look at the base as the bottom. So base is 2, right? And the height from here to here, from here to here. So each division here is 0.2, and there is 0.4. So the height is 0.4. Now, 1.5 times 2, 1/2 times 2 is 1. 1 times 0.4 is 0.4. That means this triangle here, the area under this triangle, this side is 0.6, right? Because it has to add up to 1. So this side is 0.4, this side is 0.6. All right, so here area is 0.4. Okay, good job. Let's see what's the next one. Oh, just so happens that x is greater than 3. So from here to here, and we calculated 0.4 here, so this one has to be 0.6, right? All right, let's see the next question. Again, x is greater than 3, which is again a triangle, right? A triangle. Okay, so it's half times the base, which is 2. So half times 2 is 1, times the height, which is 0.4. So this one will be 0.4. Okay, so if you have any question, you let me know. You will need the formula for some geometric shapes. Shapes like, so for example, area of trapezoid. Okay, I just want to talk about it right here. Now, trapezoid looks like this, right? So this and this is parallel, and then you have a vertical height. All right, this is what we call a trapezoid. Okay, so trapezoid is this: half times the parallel side, right? The sum of the parallel side. So that means it's A plus B times the perpendicular height, times the perpendicular height between the two parallel sides, right? So, right, hopefully that would help. And if you have any question, let me know. Thank you.